In this video, we're going over the breadth-first search approach of surrounded regions. Previously, we have performed the recursive depth-first search of surrounded regions, and now we're going to convert it into a breadth-first search approach. Let's go over the dot process. So previously, we have went through the dot process, which is basically for each of the cells which contains a value of O that's at the borders of the matrix cannot be surrounded by X. And any of the cells which also contains a value of O that's connected to an O at the borders can also not be surrounded by X. And then we can perform two scans on the input matrix. The first scan will basically find all of the unflippable cells that are connected to O's that are at the borders, and then we just change it to U. And then our second scan will flip the cells. So basically any cells that still contains the value of O will be changed of X, and any of the cells which are unflippable will be changed back to O. So let's go over the pseudocode. So we have validated the input parameter where if the board is empty, we can just return from the method because there are no cells to flip. And then we're going to iterate do all the rows. Basically, we want to flip all of change all of the O's that is connected to the first column and also the last column here. So in this case, we're not going to perform a recursive depth-first search anymore. We're going to perform a breadth-first search approach. So we're going to perform a breadth-first search on RC. We are going to create a helper method to perform this. So what parameters do we need in this helper method? We need the current row, and then the current column, and also the input board. Then in the method, if board RC does not contain a O, we can just return from the method, because we only want to perform breadth-first search from cells which has a value of O and is currently at the border, and then we can do a breadth-first search to mark all the cells into unflippable cells. So we're going to create a queue to implement BFS. Now we want to add the initial RC to BFS, not to BFS, to queue. Now we're going to mark the current cell, the initial cell, to U, basically means unflippable. Then while Q is not empty, we want to pull a RC, the row and column, from the queue. Now we want to iterate through the four directions because we want to perform our depth-first search. So four directions denoted as D. Then we want to check the new row and new column in moving in that direction. So find new row, new column in moving in this direction. So new row is equal to R plus the current direction and the delta row, and the new column is C plus the delta column, C plus the delta column. Now if the current cell at NCNR is out of bound or does not contain a O, we can just continue to next direction because there are no cells here to mark. Now we want to add NRNC to Q and then set the current cell, board NRNC, to U, basically unflippable. Now we will also perform a breadth-first search on the current row and also the last column, and then this is our second iteration. We iterate through the columns, so we're basically checking the first row and also the last row. The first row here and then the last row. So we're going to perform a breadth-first search to mark all of the cells that are unflippable. So basically the first row and also the columns. And then we're going to perform a breadth-first search approach on the last row and also the columns. Now we're going to perform our second scan. The second scan will change all of the cells that are equal to O back to X, basically saying the O is surrounded by X, so we change it. And if board RC is equal to U, we want to flip it back to 0 again. Now let's go over the time and space complexity. For the time complexity, it stays the same because this is the first scan to mark all the unflippable cells, and also this is a second scan to convert all of the cells here. Now the space complexity is O of R times C. This is because we perform our breadth first search, so we have to use our Q. This is our Q. Now let's go over the code. We will first validate the input parameter to check if the board is empty or not. If the board is empty, we can just return from the method, and then we're going to perform our first scan to check all the unflippable cells. In this case, we iterate through all the rows, so we first check the first column and also the last column, and then in this case we iterate through all of the columns, so we mark all the cells which connected to the first row and also the last row here. And now the one thing we need to change is our recursive depth first search. We want to change it to our breadth first search approach. So we'll first check if the current cell does not contain a O, we can just return from the method because we cannot mark it. Now we're going to create our Q. We want our Q to hold R and C. So we're going to use a pair to hold a R and the current row and the current column. And then we can Q.add the current row, current column, the initial starting points. And then we're going to mark the current cell to U. Now we're going to implement our breadth first search while Q is not empty. We want to pull a pair from the Q. And then we're going to retrieve the current row and column. So R is go to pair.getKey, and C is pair.getValue. Now we want to iterate through the 4 allowed directions. So in this case, the 4 directions are in this case we're going upward, this is going downward, this one's going leftward, and this one's going rightward. Now we calculate the new row, new column. Now we want to check if NRNC is out of bound or not. If the current NRNC is out of bound or does not contain a O, we can just continue to the next direction. Now we want to add, if the current cell is valid and also contains an O, we want to add it to our queue to perform our BFS, continue on. And then mark the current cell at NRNC to unflippable because it's connected to a border which contains also a value of O. And now we have finished performing our first scan to mark all the unflippable cells using breadth first search. And now we want to move upward here to perform our second scan. So we iterate through all the rows and columns. If the current cell contains an O, we want to change it to X. And then all of the cells that contains a value of U, we want to change it back to O again. Let me know if any questions in the comment section below.